Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 9th grade topic, exponential functions. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see here today, or even your own homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. Today's video will have 3 parts. So leave that like, smash the subscribe, and let's get started. So to start off our talk on exponential functions, the first question we have to ask ourselves is going to be, what is an exponential function? Now, we've talked about linear functions before, and I'm pretty sure you know about quadratics and cubics and other higher degree polynomials, but an exponential function is not similar to those. It's its own category of function. However, it does have a very similar structure to something that you should know of by now, and that is a monomial. If you know what a monomial is and how it looks, an exponential function is going to have pretty much the same exact structure. So let's say we have the monomial x squared. So we have x squared, and this is going to be our monomial. We know that the base of this monomial is x, and we know the exponent of this monomial is 2. So the variable is going to be in your base, and the constant is going to be in your exponent. This is our monomial. However, for an exponential function, you're also going to have a base and an exponent. The only thing is, you're going to have it in reverse. So instead of having your variable in your base, you're going to have your variable in your exponent. And instead of having your constant in your exponent, you're going to have your constant in your base. So you're going to have something that looks like this. This is an exponential function. Now, although they look very similar, remember, an exponential function is in a category of its own. It is not similar to polynomials at all. The only thing that is similar is that they have exponents and they have bases. But beyond that, it is not and does not behave like a polynomial. So now that we know what the exponential function looks like, let's talk about how it behaves. Because of how an exponential function is structured with a constant in the base and an ever-changing exponent, it's going to have one of 2 behaviors once you start plotting this. The first behavior is going to cause it to increase slowly in the beginning, but rapidly explode as you get further along the x-axis. And the second behavior is going to be quite the opposite. It's going to decrease very fast in the beginning, but gradually slow down as you go further and further down the x-axis. But before we get into seeing that play out, let's talk about some constraints that you have to have in order to make sure you have an exponential function. And your first constraint is that your base cannot be 1. Now, if you think about this, your base is going to be this constant number here, right? And the only thing that's changing is the exponent. Well, if you had a base of 1, you're pretty much going to be multiplying 1 by itself. 1 is a multiplicative identity. That means it does not change. Whenever you multiply 1 by itself, it's not going to change. Therefore, we're not going to get an exponential. We're going to get a constant function. And that is not the same thing as an exponential function. So in order to make sure that we have an exponential function, our base cannot be equal to 1. The second constraint is that our base cannot be less than or equal to 0. Now 0 is going to be pretty obvious. Just like how if you put a 1 here, you're not going to get anything but a constant function. 0 times 0 times 0 times it, no matter what exponent you get, you're always going to get 0. So we're not going to get an exponential function there. So that's going to be pretty obvious. Just like 1 is something that we can't have, 0 will be something that we can't have. However, negative numbers are not necessarily as obvious why we are not going to be able to get an exponential function if our base is negative. Let's plug in a few different bases and see why anything greater than 1 is going to work and anything between 0 and 1 is going to work. However, negatives will not. So let's say your exponential function was this here, y equals 2 to the x. Now, we want to plug in a few different points and see how it behaves. So you're going to have an x and you're going to have a y. So for exponential functions, there is no constraint on your x. X can be almost anything. So we're going to say it's going to be a -2. And we're going to go to -1, 0, 1, 2, and let's just do a 3 as well. When x is -2, you're going to plug that in. What do you get? Well, you get 2 to the -2. And you know, negative exponents really mean that you have to flip this, right? 2 squared, and your 2 squared is in the denominator. Well, what's 1 over 2 squared? That's 1/4. All right. How about when x is -1? So that's 2 to the -1. That's 1 over 2, which is a half. How about 0? Well, 2 to the 0, well, anything to the 0 power is going to be 1. How about 2 to the first power? Well, we're going to get 2. 2 to the second power, 4. 2 to the third power, 8. So you see how this is behaving, right? We start off really small, and it went from 1/4 to 1/2. That's not a really big jump, right? Then we went from 1/2 to 1. Okay, it's getting a little bit bigger, but still not massive, right? Now we're going from 4 to 8. That's a whole 4 spots. So you see, it starts off growing pretty slowly, but rapidly gets bigger. And if we went even further, 2 to the 4th, that's going to give us 16. And let's say we have 5. 2 to the 5th, 32. So you start at 1/4 going to 1/2. Very small change. But now we're seeing 16 going to 32. That is a massive change. And it's just going to get bigger and bigger and bigger as x increases. So this is going to be how anything greater than 1 is going to work. How about something between 0 and 1? How's that going to look? Let's say instead of having that whole number 2 as our base, we have a fraction, 1/2. Now we're going to go between 0 and 1, so we pick 1/2 as our base. Let's see how this behaves when we plug in these values for x. So when x is -2, we're going to have 1/2 raised to the -2. Now that's going to be 2 squared, right? 2 squared because of negative exponents. And 2 squared is going to give us 4. How about when you have -1? So it's 1/2 to the -1. Well, that's just going to be 2, right? And what about 1/2 to the 0? Well, 1/2 to the 0, anything to the 0 power gives us 1. All right, so you see we're kind of decreasing pretty sharply here, right? A whole 2, and then now we're going down 1. So you see the pattern here. Anything to the first power is going to give you itself, so we have 1/2 here. And then we have 1/2 raised to the second power, which is going to give us 1/4. Then we have 1/2 raised to the third power, and that's going to give us 1/8. Then we have 1/2 raised to the fourth power, and that's going to give us 1/16. Now, look at how we first started off. We started off all the way at 4, and it dropped a really quick 2, and then it dropped 1, and then it dropped half. And you see, we're dropping very fast in the beginning, but we're kind of slowing down as we get bigger and bigger x's. So it seems like when we have a whole number greater than 1, we're going to be growing much faster later on, but very slow in the beginning. But the opposite happens when you have something between 0 and 1. Between 0 and 1, you start off decreasing very fast, but you're going to slow things down as you get higher numbers for x. Now, there's one special thing that's true about exponential functions that I don't want you to miss. It doesn't matter what your base is. All exponential functions have to pass through the point 0, 1. When you have the point 0, 1 on your graph, every exponential function that you can possibly draw is going to go through this point. And if you think about it, it makes sense. Every exponential function, when you plug in 0 for that exponent, is going to have to result in 1 because anything raised to the 0 power is going to be 1. So all exponential functions go through that same point, 0, 1. What happens before that or after that point changes based on what's your base, but everything that's an exponential function will have to go through that point 0, 1. Now that we've seen that bases greater than 1 and bases between 0 and 1 result in an exponential function, let's see why negative bases do not. Let's say we have a base of -2. And I'm picking pretty easy numbers because I don't want to confuse you with the concept. Very easy numbers make it very easy to see the concept. So -2. We've done pretty much this number before, except we didn't have a negative. So let's plug in some numbers and see how it works with this base of -2. So -2 raised to the -2nd power gives us what? So we have -2 raised to the -2, and that's going to give us 1 over -2 squared, right? And that's going to be, because remember this whole thing is squared here, so that's going to be a 1/4. Make sure you're not missing your parentheses. Your parentheses is going to be very important in proving why negative bases can't work. If you don't have your parentheses, you could potentially miss out on something. How about -1? So we have a -2 raised to the -1st power, and that's going to be 1 over -2 to the 1st power, and anything to the 1st power is going to be the same thing, right? So you have 1 over -2, or just -1/2. Okay, so we went from 1/4 to a -1/2. Not a problem, right? It just decreased pretty quickly. It went from positive to negative. Not a problem though. How about 0? Well, what did we just say? All exponential functions have to go through the point 0, 1, right? So when x is 0, this has to be 1. And you can plug that in, anything to the 0 power. So -2 is no different to the 0 power is going to give you 1. So this is true. But now we have the dilemma. You don't even necessarily have to go any further than this. You start off positive, then you go negative, now you're back to positive. Can you guess what's going to happen next? What if we have a 1 here? Well, we get the same thing back and we're going to get -2. So although the absolute value of our results is showing an exponential function, the actual value is not. We're bouncing from positive to negative, and that is not an exponential function. You can keep going and you'll see that it keeps happening every time. It keeps switching back and forth from negative to positive, and the reason is whenever you have an even exponent, you're going to cancel out your negative. However, when you have an odd exponent, your negative remains. So it's always going to go from negative to positive, from positive to negative, and that is not an exponential function. So we have to make sure if we want to have an exponential function, our base has to be greater than 0, but not 1. So we couldn't wrap up this video without giving a visual on how our exponential function is going to look on a graph. So we're going to take everything we just talked about and then plot some points, and you'll see firsthand just how it grows very slowly and then explodes later on when you have a base that's greater than 1. So when x is -3, we have 2 to the -3rd power, which is just going to be a 1 over 8. And that's going to be something like over here. It's pretty close to 0, but not quite 0. So something over here. So when x is -2, that's going to be 2 to the -2nd power, which gives us a 1 over 4. So it's going to be slightly bigger, not quite a half, right? We didn't quite get to the halfway, but half of the half. So let's say a little bit bigger than that, right? How about when x is -1? Well, x is -1 gives us the half that we're looking for, right? So we got that half now. We got that half area. 0, 1, we have to pass that 0, 1. Now we have a 2, right? Because at 1, you just plug in 1, so we have that 2 here. 2, we have a 4, so we have to go up. We skip that one and go to 4. So we're going to go all the way up here. 3, 2 to the 3rd power gives us 8. So we got to go 5, 6, 7, and 8 should be all the way up here, right? So this is 8. And you just see how it's just exploding. It starts off very slow and explodes very, very quickly. We're only at 3. And if we were to 4, it would not even be able to fit on this graph here. So if you was to graph this, now pardon my handwriting here, so I'm going to try my best to connect all these dots here, it's growing very, very quickly. So this is how your graph looks when you have a base that's greater than 1. How about a base that's between 0 and 1? So now we have the exponential function 1/2 to the x. Now I wrote over here because you're gonna see I'm gonna need a little bit more space on this side of the graph that I didn't need for when our base was greater than 1. So let's plug in some values for this x. So -3, when we plug in this -3, we're gonna raise 1/2 to the -3rd power. And if you remember what we did in our previous section, that's gonna flip this and you're gonna get a value of 2 to the 3rd power, which is just gonna give us an 8. So you see, I needed something all the way up here, -2. Well, when we plug in -2, we're gonna get a value of 4 here. So it's gonna be all the way down here. So that's a pretty sharp drop, right? -1, we're going to get a value of what here? Well, that's going to be a 2 here, right? 0. All exponentials have to go through the point 0, 1. Now, a value of 1. Now we're getting to the halfway mark. So it's going to calm down a little bit. 2, that's 1/4. So it's a little less than the halfway mark. So let's get rid of some of these ticks so you can kind of see where it goes. This is going to be half of that. 3, 1/2 to the 3rd power. Wow, it's getting really small. This is 1/8 here. So there you go. And now we're going to connect all of these. It does not bounce like that. That is not what you want. It's just going to pretty much hug. And this is how your graph is going to look when you have a base that's between 0 and 1. Remember, we don't want 0 or 1, and we definitely don't want anything negative because that's just going to bounce up and down. So between 0 and 1, you get something decreasing like this. And if anything greater than 1, you got something increasing like our previous example. One additional special thing to note, on top of the fact that all exponential functions will have to go through 0, 1, you may have noticed this. If you didn't, here's our little tip for today. By themselves, exponential functions are always going to be positive. They have to be greater than 0. And the reason being is your base, the thing you're starting with, your base is always going to be positive. We just talked about that. It has to be between 0 and 1, which is positive, or greater than 1, which is positive. So when you start off at a base that's positive and you raise it to some exponent, you're not ever going to get a negative value. Now, not saying that you can't have negative exponentials. You can, because just like your monomials, remember you said that was your monomial. You can always put a -1 in front. So you can have a negative x squared. However, we know that x squared by itself is always positive. When you have a negative coefficient, now you make it always negative. The same thing happens for your exponential. If you have 2 to the x, that's always positive. But you can always throw in a coefficient in front. However, make sure that you have your parentheses, or else you're going to be thinking you have a negative base, and that's incorrect. You can always put a coefficient in front. Negative something, so let's say -2 times your 2 to the x is perfectly legal. And that negative will now make your exponential always negative. And I feel like I should say this as well. Just like you can put a coefficient in front, if you were to translate this down the y-axis, you can also get a negative that way as well. Remember, all of them have to go through 0, 1. But what if you subtract, let's say, 100 from that? You're not going to go through 0, 1 if you do that. So you can modify your exponential function, but like I was saying, just by itself, if you don't do anything else, if there's no coefficient in front, if there's no number that you're going to be translating up and down the y-axis, the exponential function at its core can never be negative. So I hope you're able to follow along to these examples, and I hope you see that exponential functions, they're pretty similar structure-wise to your monomials. However, they're vastly different from regular polynomials. If you have any question about what you saw today or even your own homework, you can always put in the comment box below. However, if the comment box is not big enough for you, feel free to visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found the video helpful. And if you found it helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping it's helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney, and this has been another session of Tutor Me Sempai.